Good morning. Today we will be talking about another important non-parametric test, which is called kruskal-wallis test. This test is used when we have more than two independent samples. It's equivalent to the one-way ANOVA of the parametric test or the completely randomized design. When the normality condition is not met in the independent samples, we use the kruskal-wallis test. What to check for normality? We usually check the residual of the dependent variable. So again, this test is used for comparison of rating between three or more groups, ranking, ordinal variables, when the residual of the other case when the residual of the dependent variable does not satisfy the normality conditions. Let's take an example of the first case, which is the comparison of the rating between the three or more groups. For the first case, we have an example. Suppose that we have three groups of consumers of different education level. Let's name this variable as the independent variable as edu group, where 1 low, 2 medium, and 3 high level of education. We're asked to indicate their level of importance as a rank from 1 to 10, not from 1 as not important to 10 very important, that they attach to price of food products during normal shopping. These are our data and our rating. Now we'll go immediately to the mini tab and see how to analyze this data. Okay, here we have our variable, which is the educational group. Three educational groups, 1, 2, and 3. Each was replicated 5 times, and we have the rating of the importance of the products corresponding to each group and replicate. Now we will go immediately. This is ordinal data. We'll go immediately to the analysis, non-parametrics, kruskal-wallis. Our response variable is the rating. The factor is the edu group. Okay. Here is our result. Again, the null hypothesis is that all medians are equal, and the alternative hypothesis, at least one median is different, because this is, as I mentioned before, it's equivalent to the one-way ANOVA. We look to the p-value of the adjusted for ties, and we can see that the p-value is more than 0.05. So there is no enough evidence to reject the null hypothesis, and there's no significant difference between the evaluation of the three groups of consumers. Now let's take the second case. The second case, when we have when the data are not normal, and to see how to check for normality and then do the kruskal-wallis test. We have an example here. We have 3 or 4 different barley lines, and we compare the chlorophyll content of the 3 groups using what's called SBDA as independent variable, soil plant development analysis, which indicates the greenish of the leaf. So we have here our independent variable and dependent variable. First of all, we have to test if the distribution of the residual of the dependent variable is normal or not. Let's see how to do this. We have to go first for ANOVA, stat, ANOVA, okay, general linear model, fit general linear model. Our response variable is the SPDA. Our factor is the lines, line. Now we have to check the graphic. We will use standardized, not regular. Change this. And we use the normal probability of residual and the residual versus fits, and to see if the distribution of the residual is normal or not. Okay, then we have to go to the storage. All right, okay, standardized residual. Okay, all right, now okay, here we can see the distribution. All right, here is the distribution of the variable of the values and the deviations of the variables from the normal line, which means the residual. Again, here is the normal line, and we want to check if this satisfy the normality or not. So now we have a new column was created, which is the standard residue. Now we want to check the normality of this residue. We'll go statistics, basic statistics. Oh, excuse me. Normality test. Now our variable is the S residual, standard residue. We use this test. Here is the result. Now it seems that the distribution is not normal because the p-value is 0.01, which is less than 0.05, and we know that the null hypothesis in case of testing normality is that the distribution is normal. Since we reject the null hypothesis of the low p-value, so the distribution of the residual of the dependent variable is not normal. Therefore, we have to go back and test using the kruskal-wallis test. So we go back to our data, the same thing that we did with the ranking. Statistics, non-parametrics, kruskal-wallis. We want to test our dependent variable. Our factor is the line. Okay, we can see here that there is a highly significant difference. If you look to the p-value, the p-value is very low, 0.001, which means that there is a highly significant difference between the different lines in their chlorophyll content. Thank you.